My name is Kent Smith. I'm the Senior Director of Product Marketing at LSI, working in the group that produces the SandForce controller chips for SSDs and flash memory. We are going to go through the new product technology we've got that is designed to increase the capacity of MLC flash in the data center. So let's first take a look at flash in the data centers. There's typically a certain number of IOPS you get for drives. If you look at HDDs, it's maybe 300. But in SSDs, you're typically in the range of 60,000. So it's a clear advantage having flash in the data center. Now, why isn't flash in all data centers for all capacities? It's really that cost per gigabyte on its own is still too high to replace all the HDDs with SSDs. And so if you look at the cost, you can see there, the ratio is still pretty big. So you want to dedicate your SSDs to only certain configurations. When you look at the typical IOPS you get per dollar though, that's where you still see there is a significant advantage to using SSDs where it makes sense. So if you're just looking at pure capacity, not performance, you'd go with HDDs, but where you need that performance, the number of IOPS you get per dollar is clearly better with SSDs. Now, what if you could triple the capacity of your SSDs using the same exact flash? Well, you get the same performance because adding more flash doesn't necessarily change your performance, so that stays the same. But your typical cost per gigabyte, that would drop from $3 down to $1 per gigabyte here in this particular scenario. So that's now a 3x drop in the SSD cost, but not the HDD. So then when you look at the IOPS per dollar, you get, of course, that 3x improvement. So now you're looking at something like 16 times higher performance per dollar. So that's a huge advantage for flash in the data center. So all we got to do is figure out how to triple the capacity of that flash. Okay, so I'm sure many people are asking, is this really feasible? Can I get this today? Well, a data reduction technology can help when the data entropy is below 100%. Let's look at this example, Oracle database. This database, this is actually from Oracle. It actually shows 30% entropy. And what that means is its size can be reduced by about 3 times. So if we look at other file types, you can see here the Oracle came in at about that 30%. As your percentage increases, it essentially is indicating less and less compressibility. So as you get to the typical JPEGs and MP3s and those type files, they're already compressed a lot, and so their entropy is very high. So in those cases, those kind of files you can't really get much out of, but you can see there's a wide spectrum of different file types that give you different entropy levels, all of which can be taken advantage of. So if we go back to the Oracle example here, if I'm running a database, I have as much as a 3x advantage in the entropy. If this is such a great deal, why isn't it being done already? If we look at on-the-fly compression issues, if we compare all the different places where engines could be located, you really need some level of predictability of that entropy. So that's one issue you have to overcome. Also, operating systems today don't understand if your overall maximum capacity of your drive can change over time. So that would be a problem that has to be overcome. In both of those cases, there are some solutions. Many data centers now have more knowledge of their data, and as well, customized drivers could be created, and there's many custom OSs that are easily modified as well. So let's look at the CPU. If we do the compression at the CPU, you're really using an expensive resource that's limiting your max throughput. And so the solution there would be, well, move it down to the device. Okay, so let's look at HDD. So could we do it at the HDD level? Well, that's really difficult because there's no variable mapping table. An HDD always assumes a one-to-one relationship from the host, so there's no way to allocate data into different capacities, different parts of the HDD. So you'd have to really significantly re-architect the HDD. For an SSD, well, you have a flash translation layer, the FTL, but you'd have to re-architect it to support that non-constant data size. So you could create a complex FTL that could manage that, and you have to focus on the data placement, garbage collection, etc. I'll note that large data centers today have tried to do this on the host side at the file system level, but that has also caused some extreme issues that have to be overcome. So, I'll say it's not a simple problem to solve, and that's really why it hasn't been addressed yet. If we look at the SSDs, are there any SSDs today that could support a variable map size? Absolutely. The LSI SandForce flash controllers today employ Dura-Write data reduction technology. This actually creates the ability to have variable size data placement on the flash. So it actually gives you the ability to cross boundaries that you wouldn't be able to otherwise. You can handle these variable size data for both reading, writing, and garbage collection. It also lets you manage the data spanning the flash page boundaries. It supports that variable data length, so the incoming data size is not restricted to a certain power of 2, which would be true in other file tables. And each of the LBAs can be a unique size. So overall, if you were to look at how Dura-Write could perform this operation, it's actually very doable. So that actually led to the introduction of our Dura-Write virtual capacity, or DVC as I may refer to it going forward. So this leverages that flexible capability inside of Dura-Write. It increases the available storage capacity of typical data, and the lower the entropy, the higher the capacity will increase. So if you recall in the Oracle database, it had that 30% entropy level. So if you were to fill a drive with that Oracle database and you would say its capacity was 1x, what you'd find is if you ran it through Dura-Write virtual capacity, you would actually have over a 3x multiple of that same capacity. Or in other words, if you started with 128 gigabytes worth of data, you could actually get over 384, probably close to 400 gigabytes of that same kind of data into 128 gigabytes of flash. So it's a huge advantage, a huge capacity increase for the user, or in this case for the database itself. So how does this work? Good question. So ultimately, the core of Dura-Write technology reduces the amount of data stored on the flash. So if we look at 120 gigabytes of user data, and we see we have 8 gigabytes of over-provisioning, so this would be a typical 128 gig physical flash SSD. Now, in that same drive, if we use just Dura-Write on its own, the 120 gigabytes gets reduced down to, let's say, 40 gigabytes, using the example of the Oracle database. Again, this is just Dura-Write, not Dura-Write virtual capacity. So what Dura-Write does is it increases the over-provisioning. So that helps improve speed and the flash endurance. You get all that from that increased over-provisioning. That you get for free. It's all automatic. Nothing has to be done. That you get with any SandForce-based SSD today. So let's look at what happens when you run it through Dura-Write virtual capacity. Take exactly the same drive, still 128 gigabytes, 120 gigabytes of user data, 8 gigabytes of over-provisioning. Now in this case, because we're using Dura-Write virtual capacity, the original 120 gig looks just like it did in the other example, but the extra space is given back to the user, so even more data could be saved there. And in this case, if we're just talking about a 1/3 or 33% entropy, we're now up to 360 gig instead of 120 gigabytes. So in this case, Dura-Write Virtual Capacity increases the user data space and does not increase the over-provisioning. So we get about the same performance as we had in the drive without Dura-Write Virtual Capacity, but we get 3 times the space. So huge advantage. Right? So let's talk about some use cases on Dura-Write Virtual Capacity. The technology itself can actually be applied 2 different ways. One with native user data storage, meaning the user themselves actually get access to a higher capacity. And the other is by dynamic caching, and that's where the host system or the application between the flash and the user would actually manage the flash directly. So you would not see this as a drive. So let's look at both of these in a little more detail. Well, we'll start with the native user data storage. So as I mentioned, this would appear as actual drive space as increased and available to the user in the SSD itself. Now the pros are the user capacity increases for that same flash cost, but the con is that you have to change the operating system. As I mentioned briefly before, the OS doesn't understand when the maximum capacity of a storage device increases or decreases over time. So this OS change is certainly easier in open operating systems like Linux or even custom OSs. It's much more difficult in closed operating systems, but certainly not impossible. Today, this particular model is supported by the LSI Nitro product line, as well as select SandForce-driven SSDs. And so the market is really the enterprise with custom OSs or Linux operating systems, as well as some client configurations with Linux as well. Now, if we look at dynamic caching, this again is the configuration where the additional flash space would be managed by the caching application itself. So that means the user doesn't see this as a drive or device, it's only seen by the caching application. So the cache increases in size or decreases in size as the data comes in, and the advantage is, of course, you get the increased cache size for that same flash cost. And it could be that same percentage increase we were looking at earlier, certainly up to 3 times on that database example. And the other advantage of that is there's no operating system change. It only has to be something that caching application understands. And that's a lot easier to do. Now, the con is, of course, you have to have an integrated caching application that's already been changed. But in the case of the LSI Nitro product line, it's already part of that product solution. It's an option that you can get. And as well, there would be select SandForce-driven SSDs that could also support that configuration. And in this case, the market for that is really the enterprise, where you have more commonly deployed caching applications. So this Dura-Write Virtual Capacity is being deployed and evaluated right now with a number of customers today, all showing some great promise for increases as we go on. So in summary, flash use in the data center is certainly expanding. Compression can greatly reduce the cost and concerns versus hard disk drives. There are major complexities around on-the-fly compression that have made it difficult to do this up till now. And the LSI Dura-Write Virtual Capacity was designed to address those concerns directly and bring all the benefits and advantages that we've talked about. As I mentioned, this capability is available today in the LSI Nitro product line and select SandForce-driven SSDs. So I appreciate your listening to the conversation here, an explanation around our Dura-Write Virtual Capacity, and I thank you very much.